All right, welcome back for another FRQ. This time we have 2016 question number 2. It's a calculator question, so you'll need to have your Inspire 89 or 84, whatever you're using, ready to go. Hopefully you've given this a shot already. We have the answer key up, and we're going to use that for our calculation so it doesn't slow us down here behind the scenes. Let's jump right in. It says for time greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals 1 plus 2 sine of t squared over 2, and the particle is at position x equals 2 at time equals 4. So first note that this is just back and forth movement, right? Positive movement to the right, negative movement to the left, and this could be anything. Don't get confused by them telling you it's a particle moving along the x-axis. It doesn't change anything. It could be a school bus moving up and down a street. It doesn't really matter here. The other thing to note from the beginning is that our initial condition is 4 comma 2, not the other way around. This 4 is our time. Time is the independent variable. The 2 is the output. That is the position. It just happens to be named x in this scenario. So be careful there. Question A. As at time equals 4, is the particle speeding up or slowing down? So for A, we want to compare the sign of the velocity at 4 to the sign of the acceleration at 4, but the acceleration is really just v prime of 4. And I'm going to use my calculator to do this, and you can see exactly what you have going on here in this window, right? They do the same exact thing here, maybe not. They do the same exact thing in this window over here, where they compare exactly what we need to be comparing with the velocity at 4 and the derivative of the velocity at 4. So pretty straightforward. It ends up slowing down because your velocity is positive while your acceleration is negative. You want to note that you need to answer the question. They say, is the particle speeding up or slowing down? You physically need to write this thing is slowing down, right? Slowing down, and the reason why it's slowing down. It's slowing down because the velocity and acceleration have different signs. That's the reason to justify. If they had the same signs, we'd be speeding up. Think about it. Positive acceleration, positive velocity, we'd be going faster and faster and faster. It'd be kind of like a snowball effect. Here we have opposing signs, so we're slowing down. So what about B? B says, find all times t on the interval 0 to 3 when the particle changes direction. Justify your answer. So this time, we're on the interval 0 to 3, and we need to figure out when we're changing direction. So I'm going to start out by finding the times when my velocity equals 0. Well, let's undo that. How about times? I want to know my times when my velocity is equal to 0. That's a nice start. If I put that in my graph screen, right, and I use my 0, not trace, but I use my 0 function in my graph screen, I can find 2.707 is the point at which this thing equals 0. Then I can look at my graph screen and I see that we change from positive to negative. The velocity itself moves from positive to negative at this time. That's my justification for finding that at this time, we do in fact change direction. So we have one change of direction, and we need to note the time there to answer the question and give that justification. Um, it's pretty straightforward, and it's not a whole lot more than that. It's 2 points, one for the time and one for the justification. Let's go to C. C says find the position of the particle at time equals 0. Well, normally if I wanted to find the position, I would take the initial position, which is in this case 2, plus the integral from the time that I had my initial position, right, to some other time, or we'll call it x in this case, right, of the integral of the velocity here. Right, so we take the initial position plus the integral from 0 to whatever my time is of the velocity. And if my time was 6, I can find out that I started at 2, and then this gives me my change over time, right? That's what this integral gives me. It gives me my change from 4 to 6. How far did I move? That's the integral of the velocity function. However, this time we don't have, come on, give me my eraser. We don't have forward time movement, so to speak. We're going backwards in time. So we're going to take the integral from 4 to 0. That is the same thing as 2 minus the integral from 0 to 4 of v of t dt. And whether you want to put this initial condition and integral into your calculator, or you want to negate it and switch it around, either way, you should end up with the same result. right, you should end up with the same negative 3.815. And I'm putting that into my calculator. I'm writing this down. I'm putting that in my calculator, writing down my answer, and I'm moving along. You can see that's worth 3 points, one for the integral, one for the initial condition, and one for the answer. So let's move to D. D asks for total distance from 0 to 3. Now, if I was finding total distance normally, I would need to get the distance we traveled forward, plus the distance we traveled backwards, plus any time we traveled forward again, and I'd have to account for that positive and negative movement and add the absolute values of those things together. However, we can kind of take a shortcut here and we can take the integral from 0 to 3 of the absolute value of the velocity function. That's going to take all those negative velocities and make them positive. Oh, I like the way that is. Put that in there. That's going to take all the negative velocities and make them positive, giving me my total distance. And that works for any time you have a velocity function and you want to find the total distance. In this case, I would use my calculator again, right? I go into my catalog and pull out ABS for absolute value, and I put my function in absolute value of whatever my velocity is, and I'd end up with 5.301 as a final answer. I'm going to make sure that on my answer sheet, I write that integral down because I'm going to put it into my calculator so that I can show my work and get points along the way. It's 1 point for the integral and 1 point for the answer. All right, 2 FRQs down, 1 to go. Give the next one a shot and then hop in and check out the solution. See you in a few minutes.